Our rule for lambda actually only covered one argument right now. It's not hard to generalize to multiple arguments. So if we have a lambda with two arguments, each of the arguments has a declared type, and that means that we're going to extend the body with both of those argument types. So in the body here, x will have type num, y will have type num. That means the body has type num here because we're adding two number typed expressions. And that means overall, we have a function that returns number and it takes two arguments. And this is how we're going to write the argument types when there's multiple of them. We just separate them by a space. So an arrow will separate the argument from the result type. And with that, we can give a type to this lambda, that same lambda applied to 5 and 6, because we have num num arrow num. 5 is a number, 6 is a number, and those two types match up in order with the expected arguments. So everything all put together has type number. On the other hand, if we expected two arguments and we only give it one, then that'll show up in the type. The type is something that wants two arguments. We have just one argument, so we can't match up one argument against the two arguments, and that will have no type. Written down more formally, we write like this, and we use this dot 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 notation to say we're matching any number of symbols, symbol 1 through symbol n, and as we do that, as we type check the body, we just add all of those into the environment at the same time. We get some type for the body expression. That is the type of the result. And then we also have to generalize application to say we've got a function and n arguments. The function needs an arrow type with n things to the left. Each of the expressions needs a type, and those types need to match up with the things to the left. And in that case, the overall application has the type of the right-hand side of the arrow.